And hello, everybody. Welcome to Digital Phorum, presented by the Philadelphia Alliance for Capital and Technology. This is Coffee with Bach. And we're here to give you a download on all things AI and emerging tech. For 15 to 20 minutes every single week, come back and understand a little bit more about what's going on in the technology space and how you can use technology practically. And tune in ahead of the Phorum Technology Conference on April 22nd, 2025 at the Comcast Technology Center in Philadelphia. And we're going to talk today with my co-host and friend, Peter Coffey. Peter?
Mike, great to be with you.
Today, I think we need to broach a topic about data. And we have all of these wonderful models, over 1 million models, Peter. There are more than 1 million models out in the wild right now on Hugging Face alone, all open source, many of them open source, of course. Yes. And that said, we've been talking a long time, probably even close to a decade, that we might be running out of data. And as it relates to models, especially, models are really rampaging through data at breakneck speeds and training on them. And what happens if we run out of data? So first question for you, are we running out of data? And if so, what do we need to do about it?
I'm going to resist the idea that we're running out of data because the capacity of the world to provide us with data has been growing in a completely amazing way. People think that Moore's law is an interesting rate of improvement on the computational side, but the growth rate of global connectivity during the time since the first pre-3G iPhone came out in 2007 has actually exceeded the Moore's law rate. In other words, the machines are being given raw material to consider more quickly than they're growing the capacity to consider it. So the ability to ingest and work with it. During Hurricane Katrina, for example, I had an opportunity to be with the Supercomputing Center at the University of California at San Diego, and they commented, as people have heard variations on this, that the bandwidth of a person on a 747 with a shoebox full of DVDs is greater than the ability to pump data across any other channel from Louisiana to San Diego. And the ability to produce a 24-hour forecast in less than 25 hours was pretty important. And so the time it took just to get the data to the machine to begin that analysis was a pretty significant fraction of the total delay in producing a forecast that would allow them to make important decisions about the allocation of emergency resources and about the movement of affected personnel. So the role of data in giving the beast something useful to do simply must be maintained at a very high level of awareness. There are two particular issues that I think only become apparent to people when there's a change in something that's been kind of context for a long time. One reminds me of the conversation when Apple introduced AFib detection in the Apple Watch, the ability to detect atrial fibrillation behavior of the heart, which was, kind of a cool thing to do, maybe with some important diagnostic ability to warn people of something before it became life-threatening. What they discovered very soon after rolling out that feature was an extremely high rate of false positives, because it doesn't take very many false positives in a population that's mostly negative before the false positives outweigh the real positives. This is just basic Bayesian statistics. It's something you get in one of your first statistics classes. But there's a more subtle issue that arose, which is that most of the data that we had on analyzing and recognizing AFib in human beings was a result of strapping a thing called a Holter monitor onto someone who'd had some cardiac symptoms and whose cardiologist wanted to get more information. So what you mostly had was a study of generally overweight or otherwise out of shape, middle-aged and older, rich white men. Those were the people who had cardiologists taking data off of them. And when those same signatures were applied to the data coming off of a young, healthy person of color playing basketball, well, was that data meaning the same thing or not? And so the sample bias that was built into what we thought we knew about recognizing a phenomenon in the wild, it turned out that once you had a much more abundant and less selective ability to ingest that data from the real world, you discovered there were sampling issues and conceptual lenses that you didn't even know were a problem until that happened. So that's one of the things that happens when you democratize access to the world's data. Another thing that I like to point out to people is that if your Tesla is driving down the road and its machine vision detects a pothole and dodges around the pothole, that's an interesting application of what some people would call AI. It's machine vision, to be more specific, but okay, call it AI if you want to. That's an interesting technology trick. I find it much more interesting that the next Tesla coming down that street doesn't need to see, recognize, and identify the pothole because it already knew it was there, because it's on the network, and the one that came down the street told the network about it, and the network, knowing that you were about to go down that same street, pushed that knowledge to your vehicle. Now, that orchestration of the global connectivity so that the right information is at the right point on the edge of the network at the right time to guide a better decision without needing to repeat the effort of detecting the problem, that's a pure data thing. That's really not about AI. That's about recognizing patterns of connection and use of data that has really nothing to do with anything that anyone in the field would call AI. And realizing that that substrate of massive connectivity, selective attention to relevant information, and delivery of that information to the right place at the right time is a task that, of course, you at Boomi are intimately aware exists and is a huge challenge for corporations. Our own most recent study, the MuleSoft connectivity benchmark at Salesforce, showed that the most recent data is that the typical enterprise has an average of 897 applications, where an application might be loosely defined as anything from a general ledger to a spreadsheet, but they're all sources or consumers of data that might have something to say to each other or that might have something they want to learn from each other. And that is a challenge of scale and complexity that kind of dwarfs the work that's being done that would appropriately be labeled as AI.
Yeah, I agree with that. I think, a lot of, what you were talking about in the co-location of, two Teslas, the first Tesla that finds the problem and, the second and to the nth Tesla or vehicles with these capabilities of extreme edge networking. That's all important, but there's also the governance of the data that doesn't belong there, or updating systems that aren't co-located. Because if you're driving in San Francisco and you're driving in Miami and you're driving in Berlin, each one of those cities is not going to have the same pothole that a car is going to experience.
No, exactly.
At the same moment in time.
And also, in detecting the fact that there's a pothole there, I don't necessarily want the training data to wind up having the fact that my particular car was driving down that particular street. Someone I know at Bell Labs, which many people don't realize is now owned by Nokia, of all things. It's not. It is a research enterprise that's owned by the company that started out with rubber boots and then got into cell phones. He said, I want you to think about this thought experiment. We've got these rules about anonymization of sensitive medical information, HIPAA in the United States, other legislation elsewhere. Okay, fine. The data sets are anonymous. But I can buy a completely anonymous data set that shows that a particular cell phone appears to spend the night really close to Peter Coffey's home address and also spends a typical day really close to the location of the company where I can readily determine Peter Coffey is employed. And interestingly, this is a hypothetical, this is not an actual fact, but hypothetically, that cell phone might also be seen to be parking in the lot of a cancer clinic once a month. At which point, despite all the anonymization of the medical data, I can make a plausible inference that Peter's got either cancer or a potentially precancerous condition. So the anonymization of the data doesn't prevent you, when you can triangulate these
Mhm.
things, from drawing inferences that could be concerning for someone who, for example, wants to be able to get health insurance or get employed or whatever. And so these capacities, the emergence, this is an emergent property in the same way that you can study the behavior of, individual molecules drifting around in empty space. And it's only when they get close together that something called sound emerges, when they start hitting each other. That's an emergent property of an atmosphere. Well, there's an emergent property of data, which is that facts that might be innocuous in isolation can lead to possibilities of inference and affecting people's choices and privacy and other considerations in ways that are not completely predictable until they're already happening.
Yeah, some things that we're talking about here. We're talking about two of many different issues with data that are going to basically train our models going forward. If our models
Yes.
have let let's bias is one angle, locality is another, emergent properties is another. I mean, there's no doubt that a lot of the early models in AI were trained on structured data, and now, like, one of the things that I think is neat about generative models in particular is they're making sense out of unstructured data, which is the vast majority of
Oh
the
yeah.
data
Oh,
that
it's
we as
huge.
humans create,
Yeah.
right?
Yeah.
Even still, Peter, I still want to tackle this problem of what happens if the models are training over web scraped data. And let's assume for a minute, as the models are today, you scrape a bunch of data on the recorded internet. And then you also sort of amalgamate data at the edge, meaning enterprise data, edge based systems, all of that. Let's assume you bring all of this data into one place and you were to train your models today on the aggregate of all of the data that exists.
Yes.
Then what? Do we have a perfect model at that point? Do we have a perfect worldview, or are we still missing something here?
Oh, well, it's the opposite of a perfect model. I mean, there's an expression, I think it's Sturgeon's law, that 90% of everything is garbage. That the average quality of data, even when it's being collected by professionals, is subject to issues of noise and error and incompleteness and whatever. The other day I bought 3 chocolate bars at a drugstore. 2 of them were $4.99 and one of them was 99 cents. And I said, "I'm sorry, I think you rang this up wrong." They said, "No, no, no, I scanned the barcode. That's what it's in. I can correct that price if you want to." And I said, "If it's just going to be trouble for you." But clearly there are gaps and inconsistencies and speed bumps, even in something as simple as making sure that a chocolate bar at the drugstore has the right price associated with its barcode.
Sure.
And these challenges become even greater. We're talking about unstructured data. And when we're talking about black boxes whose specific connection from input to output are much more challenging to analyze and verify.
Well, the fortunate thing about the model is they provide, they're really good at inference. They're really good at looking at
Yes.
variables that boggle the human mind, at
Oh, yeah.
quantitative variables that
Oh yeah, they
boggle.
they see things in patterns that a human mind might not be able to comprehend, and when we see them and we can say, "Yep, that's got some validity to it." That's a great moment.
It sure is. And, I know for, these pods, we're going to run them 15 to 20 minutes typically. I do want to touch on one thing about data and synthetic data. Um, you know, AI systems are creating new data sources now,
Yes,
especially if we want to create new sets of data and anonymize information. Then it is important for, we don't have enough information. Synthetic data is a way to do this. So AI systems can generate many new sets of data
yes.
that we can use. Is there a danger in that, or can we keep going down this, down this
Well, there's
alley?
certainly a risk, but there's also a new discipline here. To date, debugging of software has been making sure it does the right thing in a reproducible way when it's fed the same data. As long ago as 2020, I believe it was Gartner that said the next generation of debugging, if you will, is going to be the ability to craft and feed an AI a curated data set that's intended to correct it when it starts going off the rails, a therapeutic and prophylactic kind of deliberately concocted data, if you will, whose job is to improve the learning behavior of the system if it seems to have gone in a bad direction with the real data that it was getting. This is a new discipline. It's a new way of thinking about the craft of getting a machine to do what we want it to do.
Yeah, and I'm in my lab. We're looking at a couple of different data acquisition projects. And when
Yep.
I say data acquisition, it's new methods to acquire data
Yep.
that are not necessarily synthetic, by the way. And so one of the things that I'm thinking about, and maybe this is a future podcast discussion as well, is robotics. Looking at embodied AI, where you've got systems that can actually go out into the world, define their own metadata, define new methods of data gathering based on old patterns that we've done as a starting point, and create new forms of data in the actual real world to update models.
Mike, you're reminding me of something that I believe is a quote that's in Stephen Levy's book, Hackers, about some of the very early robotics work being done at MIT, when someone said, well, really, why should we limit computers to the lies people tell them through keyboards?
It's so true. It's yes, we are biased as humans, and yes, all of the data and the data structures that we've created have sort of, as you said before, maybe 90% of that is garbage, and we really need to rethink about how data is created and how we work with it. It's going to be telling how
We've
data
got
is
4
going to
more
be
episodes in
more.
which to explore some of those facets of the diamond, Mike. Yep.
Absolutely, we do. And we're going to leave it there for today. My co-host, Peter Coffey, I'm Mike Bachman. And remember to come to Pact Forum in Philadelphia on April 22nd, 2025 at the Comcast Technology Center. We look forward to seeing you there, and stay tuned for more guests on our show as well. We hope you enjoyed this episode of Digital Forum. Have a great day.